This video will describe this very simple and cheap solar heater, which is a relative of these well-known solar heaters. It is obvious that solar energy heats this black metallic surface, which transfers the heat to these trickles of water. This type of solar heaters is usually called this term, and it was invented more than 50 years ago. For example, this is an old photo of similar solar heaters, which were used for solar space heating of house. This is another example, and this is a plastic pipe for pool water. And here we see trickles of water which take the solar heat from the metal sheets of the roof. After that, the hot water enters this conventional rainwater harvesting system and returns to the pool. My idea is that these channels for water should not be vertical but horizontal, and the idea of horizontal channels has been experimentally tested with this my solar heater, where water flows are moving in these directions. Now we see how I made my solar heater, and this is aluminum foil with a thickness of 35 microns. I must warn you that this thin foil has a short lifespan, and I'm making this solar heater just for a few experiments. If you want to make a similar heater with a long lifespan, we should not use thin foil but sheets of steel or aluminum. Let's look at how water moves through my solar heater, and this is the water inlet. This is the water outlet. These arrows show the directions of the water movement between the inlet and outlet, and here we can notice small waterfalls. Now I show the waterfalls in more detail. We understand that the water is moving through my solar heater along a serpentine road, which can be depicted something like this. Unfortunately, the serpentine is accompanied by several disadvantages, which are corrected when the water moves in this way, when all the water flows move the same direction. The sun is shining now, and we can see that the inlet water temperature is 25 degrees Celsius. Solar energy heats the water, and therefore the outlet water temperature is 11 degrees higher than it was at the inlet. Of course, we can improve my solar heater, and for example, we can cover it with transparent film or glass sheets. Or we can add similar mirrors, which increase the thermal capacity of my heater and its heating temperature by about 2 times, and these experiments were shown by these my old videos a few months ago. Let's look at the advantages of our solar heater if its water flows move horizontally, compared to this well-known solar heater with vertical trickles. Now I show the first disadvantage of the well-known solar heaters, and we see these white stripes of salt, although this heater was operated only a few hours. We understand that such white stripes can degrade the appearance of the heater, but this disadvantage is absent in the new design of our solar heaters. The second disadvantage of these well-known solar heaters is losses of water due to its evaporation in the channels, but the evaporation for the new design is many times less. Our next disadvantage is relevant for cases of using similar transparent covering, which increases the temperature of water heating. Unfortunately, here we see water condensate on the inner surface of the covering of the well-known type of solar heaters, and the condensate will increase dramatically if the temperature difference between the water and ambient air will be more. It is obvious that the cause of that condensate is the evaporation of water from these channels, but the evaporation from the new type of solar heater is noticeably less. In addition, we can minimize that evaporation if we close these joints better, but we still have to find a solution, what to do with the large evaporation of water from these places. So, we can come to the general conclusion that this well-known type of solar heaters with vertical trickles is interesting for similar surfaces with a small slope angle. At the same time, our new type of solar heaters with horizontal trickles is more interesting for vertical surfaces, and for similar surfaces with a large slope angle, when those water flows move something like this. In addition, we can come to the idea of replacing those foil strips with these metal strips, which are at the same time the cladding of a house. But this idea requires finding aluminum or steel profiles of approximately this type, and unfortunately this is not an easy task. Now we will see the temperature at different points of my black aluminum foil. This temperature data tells professionals that now my heater does not work properly due to the fact that its aluminum foil is too thin, only 35 microns. In addition, professionals may notice that good efficiency of the heater is achieved if the aluminum thickness exceeds 50 or 70 microns, or they must be steel sheets with a thickness of more than 300 microns. We must draw attention to the fact that the most of the solar energy enters our heater through these zones of the foil, and the heat moves to these water flows due to the thermal conductivity of the foil. In addition, 30 or 40% of the solar energy is absorbed by these zones of the foil, and this heat moves to the water flows in downward direction, but a little of the heat moves to the flows upward.